Now, the objective number 7, that is corresponding to second example. That is how to create an equation for straight line plots. What exactly is the formula connecting length and resistance? First, after we see or we have seen that this is a straight line, we remind ourselves of something. What is it? It is that y is equal to mx plus or minus c. Do you agree? You should, because this is a straight line graph. For us to see the formula connecting resistance and length, we have to find the slope, which is m, and find vertical intercept, which is this c. Let us start with finding the slope. Like before, slope is found by saying change in vertical axis over change in horizontal axis. In this case, it is change in R over change in L, which is equal to R2 minus R1 over L2 minus L1. Before we find the slope mathematically, we must find the values of R2, R1, L2, L1, and carry out substitution with them accordingly. To start with, what is R2? R2 corresponds to whatever is here. Already, we know it without calculation. That means that R2 is equal to 0.54. Even if we insist on calculating it, we will still find it as 0.54 being the value of R2. What do we do to find it by calculation? It is by changing this equation so that V becomes the subject. Let me do it. Watch out and discover that it is now recast in a way that V is now equal to 0.006n. That is what is going to help us determine whether this place is equal to 0.54. But it is believed that we have known with the first example how this formula is to be used. Let us use it to find the value of R1. Possibly R12 corresponds to a marked position on the axis. It is 0.30. This was done deliberately to teach a lesson. The lesson is that if we are trying to find the slope and we want to make the process easy, it is good that we draw the triangle in a way that all the positions that will help us get all the values of what we require to find the slope corresponds to marked values. It is when we try and we don't succeed that we can draw a triangle anywhere. But be very sure that wherever you start drawing your triangle should be a place where this straight line crosses point of intersection between vertical and horizontal lines. You don't just start anywhere and start drawing your triangle. If you do that, you may go into the trouble of knowing exactly the value of the place where that line started. But starting where that line crossed line of intersection is a very good way of avoiding such troubles. Look at here, where I have to start. It is because this straight line crossed a point of intersection between this vertical line and this horizontal line. If I had to start from here, for instance, that would have been challenging, though still possible. So it is easier to start drawing that triangle from a place where the line crosses point of intersection. And don't forget I said that it is good to watch out for places that have been marked already on the axis. If at the end some places of interest remain unmarked, we use a formula to find their values. Let's make progress. So far, R2 is 0.54, both by calculation and by coincidence. Then R1 is equal to 0.32. In other words, we can write down the values of R2 and R1. Let's now turn our attention to finding the values of L2, L1. Do you think we are still going to locate L2, L1 as easily as we located R2 and R1? Let's check. To find the value of L2, trace it down along this line until we see what it is on the L axis. Let us see it. Going down, that meets the L axis at this point. That is this point. So what exactly is the value of L at this point? If it had been here, we would have taken it as 10. If it had been here, we would have taken it as 12. But as it were, it is at this point. It is not marked. That means we can't know what this place is until we calculate it. How do we calculate it? We turn to this formula again, but we make the V the subject. Let us see. There we go. V is equal to 0.2n. This 0.2n is a formula for knowing the value of length at this position, at this point. That is, this place is not marked, but we want to know the value corresponding to this position. So what do? We simply count how many unit boxes from origin to this point. And when we find it, we put it here in place of n and calculate it by saying 0.2 times that number. Let's count that number. Please, from here we count, from here to here, 10 boxes, 20 boxes, 30 boxes, 40, 50, 51, 52, 53, 54, 55, 56. Therefore, this n is equal to 56. What then is the value of this position? Let's find out. From this 0.2 times 56, that is 0.2. See it here, because 0.2n means 0.2 times n. So we have 0.2 times 56. N is 56. The result is 11.2. Therefore, if here is 10 and here is 12, this place is 11.2. Let's find the value of L1. Before we proceed, we recorded that the L2 is equal to 11.2. Now, L1. Like before, we trace L1 along this line until wherever it touches the horizontal axis. Let us see where it touches it. That L1 going down is along this line, going down until it meets the axis at this point. So this is the position corresponding to L1. Let's mark it. Like before, we use this formula to get the value of L at this point. Here is marked 2, here is marked 4, but here is not marked at all. Yet, that is what the value of L1 is. We must, by means of this formula, know the value of this position. Let us see. What we do is to get the number of boxes from origin before reaching this point. When we find that, we replace this n with 8 and calculate 0.2 times that number. Let's count. From here to here is 10, 11, 12, 13, 14, 15, 16, 17. 17 boxes. Therefore, to know the value of this point, we replace this n with 17. Let's see what it turns out to be. There we are, 0.2, that is 0.2 times this n, which is 17. 0.2 times 17 is equal to 3.4. Therefore, the value of length at this point is 3.4. That takes us to recording that L1 is equal to 3.4. Let's see. See it here. L1 is equal to 3.4. At this point, it seems we have everything we need to calculate the slope. R2 is 0.54, R1 is 0.30, L2 is 11.2, and L1 is equal to 3.4. I hope you followed the procedure for finding the values of all these 4 parameters we have here. The time has come for us to substitute and get the value of slope. Let's go on. Okay, to find the slope now, we do a substitution. This R2, see it here, it is 0.54. R1, it is 0.30. L2, it is 11.2. L1, it is 3.4. The summary is here. Now, we simplify. 0.54 minus 0.30 is equal to 0.24. Also, 11.2 minus 3.4 is equal to 7.8, which means that this has condensed to this. We go further. When 7.8 divides 0.24, we have approximately 0.03. Therefore, slope, that is m, is equal to 0.03 ohm per meter. That's wonderful. What it means is that every 1 meter of that wire offers 0.03 resistance. That is a wonderful way of finding the rate of change between the length and resistance of a given wire. That is not the end. What about the intercept? Before we get the actual formula connecting the length and resistance, we must look for the intercept, especially the vertical intercept. Let us see the intercept. To find the intercept, we know we should find the value of this resistance where the line of best fit crossed the vertical axis. That is here, the value of R at this point. Recall that now what we don't know is the value of this point. Let us again go back to the formula for knowing the value of every point we choose to know along this axis. What is the formula? Let's recall. As earlier known, the formula is given as V is equal to 0.006N. That is what we're going to make use of to know the value of resistance at this point. To do it, we simply count the number of boxes from origin to this point and replace this n with it. Let's count for n. N from here to this point will be from here to here 10 boxes, another 10, 20, 30, 31, 32, then roughly 33. That means that this n is 33. Let's now know the value of this resistance corresponding to this position. Let's see. Yes, 0.006 times 33 is approximately equal to 0.2. Therefore, the vertical intercept for this graph is equal to 0.2. So far, so good. We have known the slope as 0.03 ohm per meter, and we have now known the intercept as 0.2. We have now known the two main things we should know to get equation of this straight line. Let's go back to it and finally give a formula connecting length and resistance. Finally, having known that the slope, which is this m, is equal to 0.03, and intercept, which is this c, is equal to 0.2. And having also known that this y is a dependent variable that was plotted on the vertical axis, we say it is equal to r because it was r that was plotted on this vertical axis. And also having known that this x is an independent variable which is to be plotted on horizontal axis, we then replace this x with L because L was plotted there. Based on this, we now conclude that this y, which is r, is equal to this slope is 0.03, x is our L, we put our L here, plus or minus. Now we know that the intercept we had is not minus, it is plus. And our C is this 0.2. Therefore, the formula connecting resistance and length is given by R is equal to 0.03 L plus 0.2. Anytime you know the length of that wire, you can tell what resistance it is going to offer simply by putting it here in substitution and finding the value of R by calculation. That's wonderful. You agree with me?